Hi, my name is Russ, and I'm the developer of the Ensembles package. You can probably tell from the background that I'm in the Chicago area. The Ensembles package is a totally new way to do AI analytics and data science. The goal here is to simplify the process as far as it can be simplified and to make it available to as many people as possible. In particular, if you're a professional in the field already, this is going to give you an enormous number of new ways to connect up with people so you can help your customers. This is an overview of the classification function. There are others in the Ensembles package, and I'll be doing other videos about those. Classification is not specifically numbers. It's where there are things that are words. For example, types of beans or locations of something on a store shelf as good, medium, or bad. So this is going to be an overview of all of that. Don't worry if you've never done this before. You'll be able to follow it. I'm interested in your feedback, so go ahead and leave some comments in the comments below, and let's get started. This is how many of us have seen AI, analytics, data science as one person kind of plowing through whatever they got to plow through to do it. The goal of the Ensembles package to simplify everything as far as possible will stretch this to a lot more people. So it's going to be for the rest of us, which I am looking forward to this a lot. The people I've already met in the field are excellent. They're wonderful. And as a person who's done an awful lot of professional business work, I can tell you there are a lot more people who could benefit from what we can offer. So the Ensembles package is a totally new kind of AI that automates the entire data science process from beginning to end. It automatically uses both R and Python. It uses individual and ensemble models. It also uses regular and deep learning, then summarizes all that and returns all the results, and all that is done automatically for you. All models are automatically returned with no errors, no warnings, no typos, no need for you to correct anything. And it totally automates the techniques of data science grandmasters, which are ensembles, making it extremely easy for you to use those same techniques. And it only needs one line of code from you. And it's what it's doing is automatically using something called the new procedural AI. It never, ever, ever uses generative AI. I did not use generative AI for anything in this. And this is part of what we're doing to get the best possible results. So in one sentence, you provide tidy data, in this case classification data, answer a couple questions, and then the classification function will automatically return 21 results and a full report. You're going to see several fully worked out examples here. So let's start out with this one, which many of you may have already done at one point or another, and that is trying to use this data set called Carseats to determine shelving location. Can we make a model for that? Well, the answer is yes, we can, and it's a kind of a student exercise, but this is going to take it way, way, way beyond that, and it'll work for any classification data set. Instead of doing like 2 or 3 models, we're going to do 30 of them. And they're going to be R and Python, individual and ensemble, regular learning and deep learning. So we're going to be doing a lot more classification models here automatically than a lot of people do than I've ever seen actually when they do this. So let's take a look at what this looks like when we run it. First of all, load the Ensembles package, which loads in a couple of seconds. And then what we're going to do is we're going to run the classification function, but let's look at it first. We're going to look at what the data is. That's the very first thing it asks. Then what the column number is, which in this case is column number 7. We're just going to resample it a couple of times. And then we're actually going to run this. And as you'll see, it's going to run really fast. It goes really, really quick. And then it returns all this cool stuff. As it's running, it doesn't normally give you much of a progress report. So I set it up so that it will just say, resample number 1 of 1, or it'll say it's working on the ensemble section. So at least it's making progress. You know it's doing something, because sometimes these things are just sitting there and I don't know if they're running or not. And I said, wait a minute, let's fix this so we treat everybody well. There's a good idea, just treat everybody well. And as you can see, it's running and we are done. It's actually done with everything. So as our first question, do we have any errors? So let's look up warnings, which is a function. No warnings, no errors, no typos, no NAs, no anything. It ran with no errors, which is nice. So all the models were built correctly. Let's look at what it returns back to us. It returns, first of all, a data dictionary. That's the actual name of that. And then it gives us a nice data summary so you can see for each of the variables what they are. And if you look at that last one, you can see how many were good, medium, and bad. It also gives you a correlation matrix of the numerical values. This is the head, meaning the first several rows of the ensemble, so you can see how that is all set up completely, totally transparently. And it keeps going. It's going to build, these are called confusion matrices for all of the ensemble models, all the individual models, all the deep learning models. It gives you absolutely, positively everything. And it keeps going because it's going to do more stuff for you. It's going to give you the accuracy reports that you can see here. It's going to give you histograms of the numeric data, which is very nice. Box plots, and any of the red dots are outliers, which is nice. This is one I love, love, love being able to get. This is your feature, like the shelf location. And then you can see by both number and percent how many of each. I think this is very useful information. Not that hard to code, but I said let's put that in. It will also give you pairwise scatter plots so you can see everything, correlations of the numerical values, which is also very nice, and a summary report. And if you look at it under model name, guess what? The first three models are all ensembles. Gee, what a shocker. But then it gives you everything you would need. True positive, true negative, false positive, false negative, F1 score. And then it's going to give you the train test and validation. It's going to give you the overfitting amount. It's going to give you even the sum of the diagonals for every single model. So you've got a huge summary report that you can also provide if asked. In fact, the three top results, all on the holdout data, by the way, are perfect, and they are all ensembles. Gosh, what a shocker. So it works, and it works really, really well. But let's raise the bar. Can we predict on totally new classification data? So what we're going to do is we're going to transition to our second example, which is predicting on totally new classification data. So what we're going to start out with is this down at the bottom. That's going to be the data we're going to train our models on. So that's rows 11 down to the end, down to 400. And then what we're actually going to do is we're going to take those trained models, and then we're going to see how well they predict on this data, which is the new Carseat data. And if you look right at the very top, the read.csv line, I just have it stored on my computer, but you can have it stored pretty much anywhere. This is run exactly the same as what you saw a moment ago. All you need to do to change it is that one line where it says, hey, do you have new data? And it says yes. Everything else is going to be pretty much the same. And it's amazing what this will do. So again, look at this for a second. Carseat's 1, that very top line of the code, it's giving us lines 11 through 400, so it's chopping off the first 10 lines. And then, as you'll see, it's going to ask, hey, Russ, if you're saying there's new data, where is that new data? Well, you already know it's on my hard drive, so you're going to see it in just a second. So let's watch this whole thing run in real time. It's amazing how fast it runs and how quickly it goes. So we're going to load the Ensembles package and ISLR, that wonderful, wonderful, wonderful package from the great people over at Stanford and helped so many of us learn so much. Make the Carseat's 1 data set, and then the classification function. We're going to look at what the data is, column number, number of resamples. Do you have new data? Yes, I do. So that's going to be the big thing we're going to do in this, our second of 3 examples. And then we're going to split the analysis by train, test, and validation. You see at the bottom it's asking, hey, Russ, where's the new data? So I'm going to give that particular location, which in this case is my hard drive, but you could do it just as well on the internet, on a remote drive, all kinds of stuff. So go ahead and hit that, hit start, and it is running. So I have this set up so that it shows you that it's running. It's doing resample number 1 of however many you give. In this case, I did 2 resamples just because I didn't want to have you spend a lot of time watching my computer sit there and look at you. That's not a great way to run life. So it'll run the regular function, then it indicates when it's running the ensembles function as it goes through all of this. It's building all the tables, all the graphs, all the charts, everything. And It's going to be done in just a couple seconds because now it's down to the last set of ensembles, and there's the end. Yay! Okay, so let's take a look at what we've got. You can see all of the trained models in the upper right. And let's see if we have any warnings. We have no warnings again, which is nice, so no problems, no issues. We also still have, oops, if I learn how to scroll, there we go. You also still get, again, the full data dictionary, which is super, super nice. You get the full data summary, which is, again, super, super nice. Correlation matrix of the numerical values. Then there's the head of the ensemble, and then all of these confusion matrices. There's lots of them. And then we have all of the reports over here. In addition to, this time we said, hey, can you save all the trained models? So there they all are. So you can see the graphics again. For example, this is the accuracy with trained test validation. And yeah, I hit left arrow too many times. There we go. Okay. So you can see the correlation of the numerical values as either numbers or circles. Pairwise scatter plots. I love, love, love this result. It will take whichever value you're looking at, in this case, Carseat location, and then weight it against each of the features. So advertising, age, ... and give you both the actual value and the percentage, which is so nice. Box plots, each of the red dots is an outlier. Histograms, obviously, and then the accuracy plots. And then it's going to give you also the full report. So here's the full report. Try not to act surprised. All of the best scores are ensembles. Isn't that a big shocker? And then we're going to look at how did it predict on the new data, on the data that I had not seen yet. And you can see that the true value is the first row. And then you can look at the report and see, okay, which ones did really, really well. Look at them, and they're all going to have 100% accuracy. So it predicts on the new data using the trained models that we have, not just some random see how good we are. So let's take a look at what happens if you get a really large data set, and what can we do to make it easier to check. This is actually not that much of an ensembles thing as much as it's just a good data science thing. So we're going to take a look at the dry beans data set, which is pretty big. If you run the whole thing, it does take quite a while, but there's a way to create kind of a test data set, which is 1/10 or 1/20 or whatever size you want. So here's the code to make it 1/10 of the size. And then we're going to run this just as a test, just to see how this runs. So this is the code to do that. And then when it comes back, we're going to take a look at, okay, for the value we're interested in, which is, what kind of beans it is, you can see that the full value is that top number, and then the reduced one, that 10% one, is the lower one. So the first value is 0.971 for the full, and for R 0.969, and so on and so forth. So this is actually pretty darn good. In terms of a representation of the full data set, it'll give you a good idea. It's not as good as doing the full data set, but it's not bad. So you can run this, and surprise, surprise, top value turns out to be ensembles again, and it runs totally, completely fine. If you do then understand that, okay, this is going to run, we're going to be good, all we got to do is just do the full data set. Look at this. This is, I think, really, really, really cool. This is the ensembles from the reduced data set, and we get, if you run it for the full data set, I've never seen this on the dry beans data set, 100% perfect accuracy on everything. All of the main diagonals are filled, all of the off diagonals, all of them are 0 on the holdout data. So it's not on the training data, which I think is just so, so, so good. So if you're interested, you can download the Ensembles package, which does way more than you've seen in this particular video. But you can download it from that URL or look at it, actually. In order to actually get it, you would have to install it. So here's one way to install it. Install.packages, dev tools in quotes, and then load that, and then install _GitHub for the location, and then it will install this on your computer. I'm working on getting it set up so I can get it to CRAN and get it up there, but for now it is on my GitHub repository. So what can the classification solution do for you? Probably a lot, because as you can see, it's easy, it's accurate, it's very, very fast, and does some really wonderful things. So thank you very much for watching. Have a great day. Look forward to your comments. Please leave some comments in the comments below, and I'll see you in the next video.